In this video, we're going to discuss how confidence intervals can be computed. When you compute confidence intervals, what you're trying to determine is, if you repeated this procedure to construct a parameter estimate, what proportion of the time would the true value fall within a confidence interval of your estimated value? If you're constructing a 95% confidence interval, that's equivalent to a 5% significance level. You find the t-values where the value of their t-statistic will fall between the critical value for the upper value for 0.025 and the negative value corresponding to 0.025. And so what that tells you is 95% of the time, the t-ratio would fall between those values under the assumptions of your model, assuming that the effect is 0. Just manipulating this a little bit and replacing the formula for the t-value as beta hat divided by the standard error of beta hat in the case of a null hypothesis of 0, you can construct this confidence interval by just solving for beta j. The 100 times 1 minus alpha percent confidence level is given by beta j plus or minus your t-statistic times the standard error of your estimator. For forecast, this looks pretty similar to what we saw before. We already established this is a formula for the predicted variance, and we would construct 100 times 1 minus alpha percent significance level. So if alpha is 5%, this would be a 95% significance level using exactly the same type of procedure we just described. But as we noticed when we were talking about this before, the variance of the forecast error varies depending on how far we are from the sample mean. At the sample mean, if we look at the numerator of the last term in that summation, it's equal to the predicted value of the new x, one observation beyond what you have, minus the sample mean quantity squared. If you evaluate that at the sample mean, that whole term equals 0, and that drops out of the equation. So when that term is 0, the variance is just given by sigma hat squared times 1 plus 1 over n. And the further you get away from the sample mean, the larger the variance would be. So the shaded area represents a 95% confidence interval, which is smallest right at the mean, and the further you get away from this, the larger the variance in your predictions.